Hello, I'm Mark Gavor. Welcome to our third and final segment of our supply chain webinar series, Supply Chain Physics. Today, we're going to have our third and final installment. In November, we had the concept of supply chain physics. In December, we talked about the very real decision space of supply chain physics. And today, we're talking about strategies for communication and improvement. The agenda is as follows. We're going to have a recap from parts 1 and 2 and spend a little time talking about the nature of supply chain leaders. And then we're going to talk about communication, strategy, and own it, the concept basically for today's webinar. So, recapping from parts 1 and 2, why supply chain physics? It's a concept, and it's based on science, engineering, and business, and it's a set of terminology, definitions. It's basically a language and a set of principles designed to foster and enhance accountabilities across the various functions in our organization and improvements across our entire enterprise, whether the enterprise is a small company, a corporation, or even a charitable foundation. The model that we're using, the supply chain model that we use, is something that I developed many years ago and have enhanced, tweaked it over time. But in this model, you will see that we have an order taking and fulfillment part and a manufacturing part. The order taking and fulfillment, we begin with the trade who places orders. Orders are processed through the warehouse, distribution, and the goods are actually delivered back to the trade. To the manufacturing, the replenishment part of this process, it's tethered with a forecast. It goes to manufacturing planning, purchasing, who then delivers that information to the suppliers, and then the goods are manufactured, the inventory allocated to the various warehouses, and again it gets back to the trade. If you look from right to left, it's an entire information flow. Orders processed, forecast is basically an information flow, manufacturing plan is information, purchasing releases purchase orders, which is information. Now we start the flow of goods, raw and packing materials, converted to finished goods. The inventory is then allocated to warehouse, which are then picked, staged, loaded onto trucks, and distributed to the trade. We talk about 3 laws of supply chain physics, and we have these laws: the laws of interdependency, the law of constraints, and the law of information. The law of interdependency says basically inventory, service, quality, and costs are interdependent. If you're looking to improve your business, siloed or functional improvement can only take you so far in terms of inventory, service, quality, and costs. At a certain point, you reach a limit where you cannot have any further improvements unless you have cross-functional cooperation to take it to the next level. Hence the interdependency. The law of constraints. There is a limit on how much of any item or SKU can be produced in a finite amount of time. There is a limit in how far, fast, and in what quantities the goods can be shipped from point A to point B, whether the point A and point B are within the United States or the same state even, or from one side of the world to the other. And there's no coincidence that this is, we've called this the law of constraints. It is, in fact, very related to the theory of constraints. Lastly, the law of information. In this law, we want to communicate that information moves at the speed of light, well, rather the speed of the internet, which sometimes is the speed of light and sometimes is much slower. It's this law is independent of the accuracy of the information. Basically, in other words, Good information will travel at the same speed as bad information. The speed of the information is much greater than our lead times, especially as we've globalized our supply chains. And the speed of information can be much, much faster than our production rates and our ability to react to the information. We brought up the concept of supply chain whack-a-mole, and this really was used to illustrate the theory of interdependency, the law of interdependency. Quality, cost, service, and inventory. These are the things we want to optimize. We can optimize them all to a point. Then there's trade-off optimization is involved. We can improve quality at the expense of cost, or inventory at the expense of service, or service at the expense of inventory perhaps. And then if we want to improve all four simultaneously, we need some sort of structural change to our system and our method of doing business to optimize all of them simultaneously any further. When we violate the laws of supply chain physics, it's because we're not accounting for the realities of our supply chain. And what are these realities that I'm talking about? Manufacturing lead times, transit times, production rates, production capacities, warehouse space and utilization, the availability of transportation, equipment, and demand volatility. If we don't account for these properly and try to do something outside of these natural limits, or let's even call them constraints, we compromise and force trade-offs in performance in terms of inventory, service, quality, and cost. In essence, we're talking about a multi-criteria optimization problem, a very complicated multi-criteria optimization problem. We're looking to optimize cost, inventory, service, and quality. We want cost to go down, inventory to go down, service to go up, quality to go up. And it's all subject to these different constraints that we talked about. Manufacturing lead times, transit time, production rates, capacities, warehouse space and utilization, the availability of transportation equipment, and demand volatility. You might think of that as forecast accuracy. And we do this over all SKUs and across our plants or suppliers, how many plants and suppliers you have, because sometimes our suppliers produce our finished goods for us, and over X number of warehouses or distribution centers, or K in this case. This is the optimization problem we are always trying to solve. Manufacturing lead times must be greater than the manufacturing lead time for SKU I at plant J. The transit times have to be greater than or equal to the transit time for SKU I from plant J and distribution center K, etc. You can see how this gets very complicated. If you have 1,000 SKUs, 5 plants, 3 DCs, this is a very complicated problem, and there's lots of data involved. That sums up what we talked about in our first 2 seminars. Both are available on our website, www.demandcaster.com. You can go back and look at them at your leisure. We will be recording this session today, and you'll be able to see it as well. Our next agenda item is the nature of supply chain leaders. Now, I have to give you a caveat here because these are my views. This is not any kind of survey, scientific study, or a sociological, anthropological study of any kind. They're basically my opinions. The supply chain leaders, in my experience and estimation, are can-do, make-it-happen, hard-charging executives. As one supply chain SOB that I had the honor of reporting to called it, we're men of action. Therefore, we have this tank turret graphic, men of action. We make it happen. We deliver the month, the quarter, the year end. We're usually the make or break point in many of these activities, and our organizations look to us to be able to deliver in tight and constrained and chaotic times that can be the month, quarter, and year end. We do battle to overcome any obstacles that inevitably get in our way. And what are these obstacles? They're also the same obstacles that, gee whiz, we're the constraints we talked about earlier. Capacities, transportation availability, transportation times, poor forecasts, which was our demand volatility, and product changes upon product changes. How do we win? How do we mount our campaigns using this militaristic analogy a little bit further? We marshal our forces and in our factories, in our distribution centers, battling with suppliers and service providers, and also our internal partners in finance, sales, and marketing. I mean, we're fighters. We're military guys. We're men of action, right? Well, did I say battling? I didn't mean that. I meant negotiating. We don't really battle. That wouldn't be politically correct in today's climate and texture of kinder, gentler business. We negotiate. Yeah, that's it. With our suppliers and service providers, with our internal partners in finance, sales, and marketing. Great quotes from a supply chain leader, another supply chain leader that I know and value very much. He was saying, and I worked with him at a multinational company, and he told me one time, we in the XYZ subsidiary will do everything to achieve the objectives of the corporation. Why did he say this? This was an answer to a question. I asked him how he was going to supply a product at the critical year end that was in short supply and had spiking demand well beyond capacity. I was asking to help him, but I was from corporate, and while he knew and trusted me, he also knew I was from corporate and there to help, and basically one of those seagulls that we talk about all the time. He said this brusquely: we in the XYZ subsidiary will do everything to achieve the objectives of the corporation, and then he walked away. He also said one thing one time when we were talking about our tasks in general. He said, my job is to juggle, and I keep the glass balls in the air and let the rubber ones bounce. And he very well understood this theory of supply chain physics. When he talked about his job is to juggle and keeping the glass balls in the air and letting the rubber ones bounce, he clearly understood the law of constraints. Glass balls, tight constraints; rubber balls, constraints with some room or slack in it. But when he said, we in the XYZ subsidiary will do everything to achieve the objectives of the corporation, this is a classic defensive posture, basically saying, stay out of my sandbox, let me do my job, leave me alone. The case in which I was trying to help him, and I don't know that I could have helped him any more than he could have done himself, ended up being a customer service and revenue train wreck. Like I said, demand was spiking well beyond capacity. He thought he could probably, at the last minute, throw some man hours or something, or maybe he thought sales was making stuff up and the demand wouldn't come to fruition, but it ended up being a customer service and revenue train wreck. Is understanding the laws enough? My juggling colleague knew the law of constraints. In fact, he was a big proponent of the theory of constraints. Knowing the laws is not enough. We have to use them to communicate and foster what I've been talking about, the accountabilities across functions and improvements across the enterprise. So let's move into the content that I really want to talk about in today's webinar. I want to talk about communication strategy and how to own this concept of supply chain physics. Let's start with communication. Understanding the laws is not enough. We have to communicate. The problem is we have to communicate risks, things that might or might not happen. Well, there's two categories of this: that which maybe we can get done, and things that are impossible to do. It's impossible to get there from here. These are violations of the law of constraints and the law of information. When the bad news is inevitable, it's impossible to get there from here, there's no way we can make this kind of production and deliver this level of product in the time allotted. It's 2 days before the month end. We get a huge order. The product's coming from somewhere in Asia. It's a 3-week lead time. Just no way. You cannot do it. We suck it up and we do what we have to do. And what do we have to do? We walk into our boss's office, be it the general manager, president, CEO, and tell him, boss, you can't get there from here. Boss, there was a hurricane and the ship is delayed. We will not have the goods. Even though we thought we were going to have the goods in time, they're not going to get here in time. Sir, the machine broke down. We cannot get the repair part in with enough time to get production back up and deliver all the goods that we promised. If it is not certain like that, if it's iffy, if there's a probability that we can still maybe somehow get it done, we postpone. It's human nature. Everybody does this. And by postponing, we're gambling that the bad stuff won't happen. We keep people out of our sandbox and keep them from micromanaging us, because that's the other part of human nature. When we tell people, gee, I don't know, I think we can do it, maybe we can't. Me as a leader, I'm going to want to help my people get there. So I'm going to micromanage them. So it's like we go into the stay out of my sandbox mode. Yes, don't worry, we can get it done. I'm pretty sure it's going to happen. Things are good. We need to work to improve our communication of risks. Risk must be communicated. There's nothing worse than a negative surprise affecting the P&L, especially if there's no communication of any kind. It's really bad if you tell people everything is going great and then you have to